Okay, so now we introduce talk about a theorem on the relationship of being convergent and being bounded, okay, for a sequence. So, as we know from the definition of bounded, an unbounded sequence is either not bounded from above, or it's not bounded from below, or both. In any of those cases, what we know is that the terms, or some of the terms of the sequence get arbitrarily large, either negative or positive, as n gets large. And so therefore, it doesn't converge, right? It diverges, which means that being bounded is a necessary condition for convergence, which leads us to this theorem. And so this theorem simply states that if a sequence converges, then it must be bounded, which is the necessary condition. Okay? Now, the sequence converges is a sufficient condition, but the necessary condition is that it be a bounded sequence. Okay? And that's it. So, one of the things too is to, let's see, if we note that if a sequence is bounded, right? If the sequence is bounded, it's not sufficient, right? It's not a sufficient condition for a sequence to converge. Okay, it's a necessary condition, but it's not a sufficient condition. So just because how do I put this? So we know, if we know that a sequence converges, then automatically we know that it has to be bounded, because this is a sufficient condition. So being convergent is a sufficient condition to show that a sequence is bounded, right? So if this is true, then it must be true that the sequence is bounded, but it doesn't go the other way around, okay? So being bounded is necessary for convergence, but it's not sufficient for convergence, okay? So this implication doesn't go the other way, in other words, okay? So it's not, if the sequence is bounded, then the sequence must converge. That's not necessarily true, because we could take an example, an example that violates that, right? So again, the easy one is this. Whoops. If we consider the sequence, -1 to the nth power, well, this is a bounded sequence, right? It's bounded above by 1, right? So this oscillates between 1 and -1. But this is a divergent sequence, as we know. So even though this is a bounded sequence, it's divergent because it doesn't approach any particular value as n gets arbitrarily large. Okay? So keep that in mind, that just because something is bounded doesn't necessarily mean it converges. But if we know that a sequence is convergent, then we automatically know that it's going to be bounded. What else can we say? Okay. That's it for now. Have a great day.